Hello children, this is Ashani from Cheenta.com. In this video, we will talk about a problem from Math Kangaroo. Math Kangaroo is a math Olympiad that is conducted in different parts of the world. This one is from Canada. For our students, especially junior students from grade 1 to grade 6 and 7, we actually recommend this contest because it has many beautiful problems. So let's look into one such problem, and also I'll give you a challenge in this video. If you can solve it, please put that in the comment section. Okay, all right. So this problem says that you have a cube. So maybe I can draw a cube like this here. You have a cube and you want to draw the net of this cube. You want to draw the net of this cube. So what that means is you want to open up the cube and lay it flat. You want to open up the cube and lay it flat. Okay. So maybe I can just change it to standard eraser and remove some of these weirdities. Okay. So this is a sort of a cube. So what you do is you unglue some of the edges and you open it up and make it flat. So it's like a flat piece of paper which you can fold it back up into a cube. Now there are many ways of doing this. The flat version is sometimes known as the net of the cube. There are many ways of doing this. One way is this one. You open this up and lay it flat. So another way, let's draw another way. And this is a more common way of doing it. That is, you have like a T. Okay. So you have something like this. And you have two box squares like this. So if you notice that the cube has, of course, 6 faces. The cube has 6 faces, the top, the bottom, and the 4 walls, right? So if you open it up, there will be 6 faces, will be 6 squares in the flattened out cube. So whatever figure you get, you are actually going to get 6 squares in that figure. Okay, so can you tell me now, this is a challenge question. Here's a challenge. How many types of nets of a cube can we have? So I just drew 2 of them. This is 1. This is 2. Can you count and tell me how many different types of net of a cube that we can have? If you are in a Math Olympiad program at Cheenta, then you are already facing challenges like this every day. That makes you think. Remember, it's not about remembering formulas. It's about thinking critically about problems. And in case you are new to this channel and you do not know much about us, we conduct beautiful math, physics, and computer science programs for Olympiads, for the real Olympiads. You can check the link in the description for more details. Okay, so let's go back to this. So we have opened up this cube. Now the question is, if you add the numbers on the opposite faces, then what would be the sum of the numbers? So if you fold this back up, of course you will get this cube, and now the numbers will show up in the opposite faces. So for example, one number will show up here, one number will show up in the opposite face of that. So you add these 2 numbers. Similarly, one number will show up here, one number will show up here. You add those 2 numbers. So there will be 3 pairs of opposite faces. You want to add those numbers up. And what will you get? That's the question. So the trick, I mean, of course, you can just observe and try and do this. That's fine. That's part of pattern recognition. But in this video, we will learn to think methodically. So when we look at two opposite faces, the way we're going to think about it is that they are only one square apart, which means there are exactly one square between two opposite faces. If you really open it up, this face and this face has only this square in between them. That's the trick. That's the key idea, key observation, that if you have two opposite faces, only one square is coming in between them. Okay, so one square is adjacent to both of them. Adjacent means it's touching both of them. One square is touching both of them. This is the key thing that we're going to use in this problem. For example, if let's look at the square 1, which is the other square that is one square apart? Well, it's 3, right? Just one square is coming between 1 and 3. So these two must be opposites. So 1 and 1 plus 3, that's one pair. Similarly, we have 2 and 4, because that's another pair. Exactly one square is coming between them, 2 and 4. And clearly, 5 and 6 would be the other square. It's not really one square that's coming between them. You can't see it like that, but one edge is there. So that will fold back up and make two opposite sides. So 5 plus 6. 5 plus 6. So you have 4, you have 6, and you have 11. So the answer is 4, 6, and 11. The pair of opposite numbers add up to this. And the main observation is how many squares are coming in between them. Okay, so here is another challenge. So challenge 2. And we talk about the platonic solids in our Math Olympiad programs for little kids. And I'm going to draw another platonic solid. It's called the octahedron. So let's draw this carefully, and you can also draw it in your notebook if you want. So it's an octahedron. Right? So it's kind of like this. Okay, here we go. So it's a 8-faced solid. So it's octahedron. So I want you to try and open up the octahedron and lay it flat and see how it looks like as a second challenge. There is a relation between the octahedron and the cube. We actually discuss it in much more detail in some of the math programs that we have. They are in some sense they are dual solids. Quite fun actually. But for this particular challenge, just go ahead and open up the octahedron and lay it flat and check how it looks like. All right? So these are the two challenges. I hope you like this problem. I hope you learned something from it, from the key observation, how to think about such solids. I hope you will be able to open up your minds and try some more beautiful problems. Thank you for joining us today. I'll see you in the next one. All the best and keep on doing good problems. Okay?